Alrighty, everybody, we are going to hit chapter 2, and we're going to do these notes backwards because they're filled in. And so I'll be erasing as we go so you can see what you should be putting into your notes. Keep in mind that you can just write them onto regular paper, or you can look these up later if you need help because they'll be posted as filled in notes as well. So we're going to actually break 2-1 into 2 days. It's a lot of vocabulary and just applying that vocabulary so that you know what the words mean and can find things that fall into each category. So that takes a little bit of memorizing, which takes a little practice. So we'll do that for a couple of days. So the first thing that we're going to do is talk about integers and rational numbers. And the only way we can talk about them is if we know what they are. So we use the word whole number, and a lot of people think, oh, that just means it's not a fraction. So when you're mathematically defining a whole number, that's going to be 0, 1, 2, 3. So if you notice one thing here, whole numbers are 0 and positive numbers. So we don't count negative numbers like -2, -3. Even though they aren't fractions, they still are not considered whole numbers. So whole numbers start from 0 and go on up. How does that vary from the word integer then? Let's take a look. So an integer is any number, again, not fractions, but you'll notice that now we're going to include the negatives as well. So that's how these two are different, and you want to start learning how they're different from one another. So integers are also 0, 1, 2, 3, 4, like the whole numbers, but it also goes the other direction and includes -1, -2, -3, and so on. We still aren't talking about fractions. We still aren't talking about decimals. Rational numbers, which is going to mean there's probably irrational, but rational numbers is going to mean that a number that can be written as a quotient. So that's kind of fancy terms. Quotient basically means it can be written as a fraction. The problem is sometimes these will be decimals. So if it's a decimal, it has to terminate or end. So if you have a decimal, then it either has to be, I'm going to write end just for space. So like 0.25, that is a rational number because it can be written as 1/4. The other thing it can do besides end is it has to be a repeating decimal otherwise. So for example, if you have 0.3 with a repeating sign over it, meaning 0.3333 forever and ever, that actually can be written as the fraction 1/3. So those are decimals, but they are numbers that can be written as the quotient or fraction of two integers. So when you're talking about rational numbers, then there's another type of number which is not rational. Now that vocabulary term is not on here, but I want you to kind of think about what that would mean. And I'm going to put that up here just so you have a spot to kind of think about it. Something that is not rational, meaning it's called irrational, would maybe be something like pi. If you do pi in your calculator, it goes on and on forever. If you did the square root of 2 on your calculator, it goes on and on forever. So these are decimals that don't end, so they never end or repeat. So it's completely the math opposite of what we're talking about in the rational numbers. These either stop, like 0.25, or they repeat. That will make them rational. Whereas irrational means that it's just going to go on and on forever. It's never going to stop. It's never going to repeat. You can't really contain it. It's an irrational number. So you see we have more vocabulary terms, but we're going to save those for tomorrow so that we have some fun things to look at then. So let's just look at some examples that deal with the terminology we learned today. So it says to graph -2 and -5, tell which number is less. So these are comparing integers. So we're doing two things today. We're learning those terms so that we can classify numbers and say, are they whole numbers? Are they integers? Are they rational? And then we also are figuring out which one is less or greater, keeping in mind that on the number line, the things that are greater are going to be to the right end, and the things that are less are going to be over to the left. So if you have 0, keep in mind that when you go negative, you're kind of counting backwards because you have -1, and then you have -2, which is one of the dots that we're trying to graph. Then I go -3, -4, and then I hit -5, which is the second dot that I'm trying to graph, or the second value. So when I look at my two numbers graphed, and those are both integers, they're not fractions, they're not decimals, but they are negative. So these would be integers, but these are not considered whole numbers because they are negatives, just to kind of keep thinking about those terms. So really when I'm looking and it says tell which number is left, that really means that it's more to the left. And so when I look at it visually, it helps my brain say, oh, that's going to be the -5. So on the number line, -5 is to the left of -2. So, and then we're writing that statement mathematically. And you would read this as -5 is less than -2, because that really means it's to the left of. So it's not really complicated calculation today. You just have to think, and probably drawing it out will help you a lot. Alrighty, so now we're going to classify numbers. Classify means we're going to decide, are they whole numbers, are they integers, are they rational, or not? And we have to think about what that means. So keeping in mind that whole numbers is like 0, 1, 2, 3, and so on. Integers is also 0, 1, 2, 3. So some numbers will qualify as both, but this also can go the other direction in negatives. And then the rational numbers, this can include fractions, this can include decimals, as long as those decimals, either end or repeat. And it certainly can include whole numbers, fractions, decimals, and whole numbers, because if you say 2, that can be written as 2/1. And remember, our rule for rational numbers is that it has to be able to be written as the quotient or fraction of two values. So really anything that's a whole number or an integer is also going to be rational. So it's tricky to remember, and that's why we keep practicing that vocabulary. So 3, does that fall into our category for whole numbers? Sure does. Is it also an integer? Well, if it's a whole number, it's going to also be an integer every time, because whole numbers as an entire set of numbers are included in the integers. So like if you have whole numbers as a set, they're going to be completely included in integers, because integers are a bigger set of numbers. They're the whole numbers, but also adding negatives. And then rational numbers is going to be an even bigger set than that, because it includes positive numbers, negative numbers, whole numbers, integers, plus fractions, decimals that end in repeat. So they're all kind of contained within one another. So because it's already both whole and an integer, then it's definitely going to be a rational number. Because if it's living inside one of these interior ones, then it has to be a part of that exterior one, because it's contained within it. So as you get further and further out, it'll contain all of those subgroups that are inside of that. So how about 1.7? Well, 1.7 doesn't seem to be in my list of whole numbers because it's no fractions, no decimals. So that one I expect to be a no. How about an integer? The only thing that integers do differently than whole numbers is they include negatives, but still no fractions or decimals. So I expect that to be a no. But 1.7, is it rational? Well, it's not a fraction, but it is a decimal that ends. So that one is actually going to be a yes, meaning if I was placing that 1.7 someplace in my little chart over here, 1.7 lives out here, where it is in the rational, but not contained in the integers, not contained inside whole numbers. How about negative 1.4? Whole numbers have to be positive, so that's a no already, plus it can't be a decimal or fraction. Can negative 1.4 go and become a part of the integer club? Well, integers accept negatives, but they still don't accept decimals or fractions, so that should be a no. Oh my gosh, I'm so blind. That's a 14. Haha, sorry. So the reason that this one can't be a no is that it's negative. But since it's 14, now that I can see, that does fall into this category because it's not a decimal or a fraction. So that one's living in the integers, which means it definitely is going to have to also be rational, because rational is any integer, whole number, and then fractions, decimals beyond. So as you can see from our list, it's really hard to not be a rational number. Most numbers are rational that we deal with in math. All right, I'm going to actually pay attention and look with my eyes here. This one's negative 1/2. So two issues with that here in the whole number category. It is not positive and it is a fraction. So I'm expecting that one to be a no. How about an integer? So again, integers will accept negatives, but this one's not a whole number of any sort. It's got a fraction, so I'm expecting that to be a no. How about rational? Well, we decided it's not whole or an integer, but it is a fraction. And then it's negative, which is not an issue. Rational can be positive or negative. So I'm expecting that to be a yes. So then if I was negative 1/2, I'd be living out in this region again where I'm not included in the whole numbers. I'm not included into the integers, but I am included in the rational number parts. So just kind of try to get a sense of what belongs where. So our other skill today besides classifying is ordering the numbers, putting them in order. So this table shows the low daily temperatures for a town over a 5-day period. We're going to order the days from warmest to coldest, so pay attention to that. So if you wanted to kind of draw yourself a number line, you certainly could, because sometimes visually we do better with that. So I'm going to put a 0 in the middle, and that's actually one of my numbers, so I'm crossing that off. 10 is going to be positive, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right over here. Cross that off. Negative 2 is right over here. So I have these 3 spots kind of located on my number line so far. Positive 1, 2, 3, 4, 5 is going to be here. And then my last one's negative 7. So negative 1, 2, 3, 4, 5, 6, 7. So be careful, because the last time we were asked to put them in order from least to greatest, which meant left to right, this says warmest to coldest. So this wants us to order the days from the numbers farthest to the right down to the numbers on the left. So if we wrote our numbers out, we would have 10, 5, 0, negative 2, negative 7. That is warmest to coldest. So then if we tie that back to which days are what, then we're going to be able to see what days went where. So there's our number line, and it goes from day 2, which was 10 degrees, then the next was day 4, which was 5, and so on. So when you put them in the order of the warmest to coldest, that's what you're looking at. Okay, so if we read the numbers from left to right, which it's telling me to do here, that's what the order is, but from warmest to coldest is going to end up where we ended up. And these are the days, so don't get confused about why the numbers changed. This 2 is because on day 2, it was 10 degrees. So these numbers still go with ours. On day 4 in my chart, it was 5 degrees. So we're still following along in these. The day that was 0 degrees was day 1. The day that was negative 2 degrees was day 3. And then day 5 was the coldest day at negative 7 degrees. So just kind of pay attention, because it's asking for the days, which is this top row, rather than the actual temperatures like we had here when we put them in order. All right, awesome. So this is actually kind of the end of day 1, because we're going to save the other stuff until tomorrow. So here we're just going to tell whether each of the following is a whole number. So we're revisiting that. Keep in mind, whole numbers means no fractions, no decimals, no negatives. Integers, still no fractions, no decimals, but now you can accept negatives. Or rational, which is taking all the whole numbers, all the integers, even fractions, and even some decimals, as long as they end or repeat. So let's take a look. Oh my gosh, we have 2 things to do, because then we have to put them in order. So much work to do. All right, so the first thing, let's take a look at 0.8. Is 0.8 a whole number? Heck no, because it is a decimal. How about integers? Well, no, you can't be an integer if you weren't a whole number. How about a rational number? Well, it's a decimal, but it ends. So 0.8 is going to be rational only. Alrighty. How about negative 17? Negative 17 can't be a whole number, because whole numbers don't accept negatives. But negative 17 can be an integer, and then it can also be a rational number, because remember, whole numbers, every single one of them is an integer, and then every single one of them is rational. How about we take a look at this one? This one's kind of tricky, but if you take a look at -5 3/4, change that into a decimal on your calculator and you'll have -5.75. And that's going to make you maybe be able to put it in order easier. But now when you look at it, it's certainly not a whole number because it's negative and a fraction or decimal. It's not an integer because even though they accept negatives, they don't take fractions or decimals. But it is still rational because it's written as a fraction, and when it's written as a decimal, it is an ending or a terminating decimal. And then 2. 2 is a pretty easy number. 2 is a whole number. And since it's a whole number, it already lives in the integers, so it's going to also be an integer. And then because that's inside of rationals, it's going to also be a rational one. So if you wanted to put these in number line order, you'd be looking from left to right because it says least to greatest. So if we do that, the number that would be farthest to the left would be our -17. So let's see here. So if I look at my numbers, my farthest left, get my pen back here, is -17. Then my next negative, as I get closer to 0 on the number line, would be the -5 3/4. Then as I go into the positives, 0.8 is going to be less than +2. So that's the kinds of things you need to be thinking about. We need to be thinking about what's the classification and then what order do they go in. All right, I'm going to go up here and write down your assignment for today. You're going to be looking on page 67. You're going to do number 1, number 3, 5 through 10, do all of those. 14, 19, 22, 53, 54, and 63. So when you're done with those, then open up your assignment check. Make sure that you have written down your work, boxed in your answers, so that when it comes time to transfer your assignment check answers, you can just go right through it in the 10 minutes that you have. And then we'll finish up 2.1 tomorrow. Thanks, guys. Bye.